So hello everyone. Uh, in the last video we have seen the arithmetic operation. In this video we will see the data types, what types of data we use in C++. So mainly there are two types of data. First one is primitive data type, second one is non-primitive data type. So in primitive data types, int, float, char, double, these things are come. And in non-primitive data types, we have array, linked list, structure, union, etc. So in this video, we will study more about the primitive data types, because these are the data types we mostly use. And for these non-primitive data types, we will have separate video. And because these are bigger topics, array, linked list, structures, we will study in brief. So let's talk about primitive data type. So in primitive data type we have int, float, char. So int for integer. So if you want to store some integer value in a variable, then that variable should be declared as a int. Okay. Float is for floating point value. Decimal value is basically 4.6, 3.2, this kind of value you have to store in float. So char for character, any single character, any keyword, ABC, hash, $, all the character, any single character. If you want to store in a variable, you have to declare that variable in as a char. Okay. Double for bigger decimal values number. Okay. Short int, long int, we will study it. We will look into it. So first we see some keyword. So signed and unsigned keyword, what they means is, so if you use signed in front of the variable declaration, that means this variable will be can be positive or negative, can store positive or negative values, right? If you if a variable is declared as unsigned int, that means this variable will only contain positive values. Okay. So this keywords helps compiler to 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 know the variable type of variable very briefly. Okay. So let's see how this short int, long int, and signed int, these are different. Okay. So they are different in terms of size, in terms of memory they take in the system. Okay. So suppose if we talk about int, we have 2 or 4 bytes of memory for that. Okay. So when we declare a variable as int var, that means that var will allocate 32 bits of memory in the system, max 32 bit. It can minimum 2 bytes, means 16 bit, right? So suppose we have a variable declaration as signed int var. Okay. Now this will take 4 bytes of memory in the system. So 4 bytes of memory in the system means we can assign the value in this range. Okay. And this comes from a formula. So the formula is 2 to the power number of bits minus 1 2 to the power number of bits minus 1. Okay, minus 2 to the power number of bits minus 1 minus 1 to 2 to the power number of bits minus 1 minus 1. Okay, so in this range your value can be allocated in this variable if you are writing signed int. Okay, for unsigned int, as you know that we don't have negative values, we have only positive values. So we can store in this range values 0 to 2 to the power 32 minus 1. 32 is number of bits. Okay, to 0 to 2 to the power number of bits minus 1. Okay, so in this range you can store value in this variable name. Okay, now let's see about what are the difference between this. Okay, int, so we have already seen for int we have 2 or 4 bytes of space. For short int we have 2 bytes of space. For long int we have 4 bytes of space. For long int we have 8 bytes of space, right? And for we have also float. So for float we have 4 bytes of space. For double we have 8 bytes of space. For char we have 1 byte of space. Okay, so these are the space that takes in the memory. Okay, in the system actually. So suppose why we have double and float, and for why we have so much variant of int, short int, long int, long int, why we have, why these things are needed. Okay, so suppose you have a smaller number. Okay, you have a smaller number and you want to store in a variable. So what you have to be precise so that your code will be efficient, your code will be optimized. So you have to be precise with the variable type, with data types of your variable. So you know that your value in that var will be very small. So you can use small in like short int, so that will takes only 2 bytes of memory. Okay, and if you don't use short int, if you use long int, that will also store the value, but for smaller value you are storing a like larger space, so that uh, space will be wasted. Okay, so that will affect your code quality and code efficiency. Okay, so for this we have this much variation of int, like. And also one more thing is that like for short int, like for let's say you have a bigger number and we have short int, so we cannot store bigger numbers in a short int because we have only 2 bytes of space, so we cannot store bigger number. So what will happen if I store a bigger number in that variable, that will the compiler will not store the actual values of your variable in that space. It will gives you when you like you do the assignment, right? But when you get the variable value na, you will get the garbage value, you will get some random values. Okay, so let's see, we have some let's see some example. So suppose we have long int this much value here, and we are printing the var. Okay, and we are also printing the size of var. Okay, same for float, same for char. Okay, so let's run this. So first we will compile it. So compilation is successful, we have to run it. See, so what did you get? You get 8. Okay, you get the value right, where you get the size 8. Size 8 means long int is of 8 bytes. I have told you that long int have 8 bytes. Okay, now float. So float have value 2.343. So this is the value, this is the size 4 byte, and this is the char, this is the size. Okay, now suppose if I store this value in a sort int. Okay, sort int, then let's see what happens. So suppose it here itself it's giving a warning. It's a warning, means it is not an error, so your code is compiled successfully within warning. It's a warning, so you compile it again. No, you have compiled it already, so we will run it. So you get this value 4836. We did not store 4836 in var, right? So this is the garbage value. We are getting some random values instead of actual values. So this is the problem when you use inappropriate data types while storing the values, right? So now for this, for double also we have the same situation here. If you want to store like larger decimal values, you have to use double instead of float. Okay, so that's it for this video. Now we will see these things in more details in an upcoming videos. So till then, keep coding and let me know if you have anything in comment section. Bye.